Okay guys, this is the last video for integration by parts. Alright, so I choose question number 9 for our discussion. Alright, if you look into the question there, okay, we can say that tabula is not suitable here because based on the LIATE, so you can say that this part is your exponent E and this is the trigo function. So based on the word LIATE, trigo come first before exponent. So if you try to differentiate cos, it will never be 0. So you can see that you cannot use tabula. So here let us use the integration by part. So for integration by part, basically you need to find these four things: u, dv, du, and also v. Okay, you can recall under my previous video for it. Okay. So in order to choose the value of u here, you can go for trigo because trigo come first before exponent. Trigo come first before exponent. So you can say that here it will be cos x, and here it will be exponent to the power of x. Okay, so differentiate. Cos, it will be negative sign x, and don't forget to put dx at the back of it. And if you integrate exponent x, you are going to get here exponent 2x. Again, integrate, you are going to divide it by differentiation of 2x, which is supposed to be 2 there. Why it's not appear there? Alright. So you're going to get the main frame something like this. Okay, so if you write back the formula, you are going to get here the integration of exponent 2x cos x dx is equals to uv minus integration v. So let us proceed from here. So the value of u and v can be obtained from our main frame here. So u and v. So quickly you can just rearrange that and multiply it. So you're going to get here exponent 2x cos x over 2 minus with the integration of v du. So here is supposed to be minus. So minus and minus, you are going to get plus 1 over 2. Because you got 1 over 2 here. 2. Exponent 2x sin x. Okay, if you look again on this part, you are required to deal with another IBP. Again. So you need to reset all your mainframe here. So you need to put it again on this part. So you can actually pause this video and try to do by your own. What is the new du? What is your new u du? What is the new dv? And what is the new value for your v? Is on that part. Okay. Because I was in a video here, so I don't want to pause it and let me proceed. Okay, now again you can see that you have exponent and also trigo. So here of course it will be a priority place for trigo. So sin x, if you differentiate sin x, of course you are going to get here cos x dx. You can refer to the table in the mathematics 1 book. Okay, the value of dv here is supposed to be exponent to x dx. So if you try to integrate it, you are going to get here exponent to x. Write it again, you are going to divide it by 2. So what we did previously is, okay, this is your answer already. So you need to write it back, which is exponent of power of 2x cos x over 2 plus with 1 over 2. So write back with a plus 1 over 2. So starting from the integrals up to the dx here, you can start to change it into uv minus with the integration. Okay, so don't pick the old u and your old uv. You need to go for the new one here. So you are going to get here the exponent of 2x cos, okay, 2x over 2 plus with 1 over 2. So your u, v, and du is already there. So you just need to multiply it. You can do it quickly here, which is it will be u times v. It will be exponent 2x cos x over 2 minus with the integration v du. Where's the value of v here? So value of v du. So you are going to get here 1 over 2, because over 2 there is actually 1 over 2 e to x cos x dx. Okay, close the bracket. So now let us open the bracket, but before that you need to multiply this part and also this part together. So here you are going to get equals to exponent 2x cos 2x over 2. 1 over 2 multiply with 2 here, you are going to get plus with 1 over 4 exponent 2x cos x. So 1 over 2 multiply with another 1 over 2, it will be minus with 1 over 4 integrate exponent 2x cos x. Okay, look like you need to do another integration by part here, but wait, before that, let us go back to our question. If you look into the main question, this is our main question. It's actually integrate exponent to x cos x dx. And now, if you try to compare it with this one, basically you are going to get the same question. So you can write it back here. Integrate exponent 2x cos x dx is equals to all this. So if you try to deal with the integration by parts for this part, exponent 2x, you are going to repeat all the same thing again and again. Okay, all the calculation will be repeated. So how to solve it? So in order for us to solve this part, what we are going to do, we are going to bring all this value, negative 1 over 4, to your right hand side, which is you are going to get here the new expression. Let me bring it down. You are going to get the integration of exponent 2x cos x dx. So you have a minus there, minus here, you bring to the other side, it become plus with the integration of 1 over 4 exponent 2x cos x dx is equals to all this part, which is you're going to get here exponent 2x cos 2x over 2 plus with 1 over 4 exponent 2x cos x. Alright, if you see here, we have the same thing, x cos x and ex cos x. So it will be actually equals to 1 plus with 1 over 4 multiplied by the exponent of 2x cos x dx is equals to exponent 2x cos 2x over 2 plus with 1 over 4 e to x cos x. Okay, let us see in the next video on how do I solve this part, because I'm run out of time there. If you want to total this part, you are going to get 1 over 5, and you're going to get 5 over 4. So now we want to left with this part. So we are going to get here the integration of exponent 2x cos x dx. We can bring the 5 over 4 to the other side. It become 4 over 5. Multiply with exponent 2x cos 2x over 2 plus with 1 over 4 exponent 2x cos x. Okay, and for the last final answer, you can actually multiply this term, and also this term also can be multiplied to get the final answer, which is you are going to get full solution for it. And don't forget to mention the plus C at the back of it. Okay, you can either stop there. So you can try to deal with question number the next question here. So you can deal with the question number 10 after this, which is you need to apply the same method. Alright, so thank you class. So see you with the exercise and also quiz later.